Let's first start by understanding what a matrix is. So we know what a vector is, right? And we basically say that a vector is just, let's say if you have a vector, a variable called vector, right? It's just going to be an array of numbers, or a list of numbers. 1, 2, 3, 4. Right? This is a vector, right? It's just going to be a list of numbers separated by commas. Now we are going to something called matrix in mathematics. When we are working with machine learning, you'll be majorly be working with most of the things in columns and rows in tables, right? But mathematically, to handle them, we use the concept of matrix to do a lot of stuff in machine learning. So in matrices are generally labeled, let's say A equals to, then this matrix can contain a lot of things, right? So 1, 2, 4, 3, 1, 6, for example. This is an example of a matrix. It's a rectangular array of numbers, right? So what happens is we have some number of rows. So the rows are counted like this. This, like going like this, is a row. So rows are like this. If you are looking at it this way, this is a one row, this is another row, and the ones here are columns. They are just like tables, right? So each, if you are reading it like this, these are one column, second column, and third column, right? So the dimension of this matrix is, so the number of rows times the number of columns by the number of columns. That is it. So how many rows do we have? We have one here, one going like this, another one going like this. That will be two rows, right? By how many columns? 1, 2, 3, by 3 columns, right? Yeah, so 2 by 3 matrix. This is a 2 by 3 matrix. Okay, so now how do we do that in Python when you are actually using the Python? So what happens is that each row is going to be supposed to be a list. Each row that you have here is going to be a list. This one is going to be a list. One thing to keep in mind is that the number of items that you have in one row should be the same across all the other rows. So if you have another row, one row that is, you can have something like row 1 to be 1, 2, 4, and then the second we have 3, 1. This one is not going to work. Then the first row is row 1, right? Let me say R1, and this one is R2. They are all part of the same matrix or the same rectangular arrangement. But in matrix, you have to make sure that if the first row has 3 items, make sure that the second row, the following up rows also have the same like the same number of items. So this is 1, 2, 3. This one also contains, this second row is supposed to be also 1, 2, 3. If you are doing a 2 by 2 matrix, I can have like 1, 2, this is one row, 3, 4, another row, 5, 6. You can see that the number of items in each row, this is row 1, this is row 2, and this is row 3, are the same. The number of items, or the number of columns, right? The individual number of items, this is column 1. So column 1 contains this, column 2 contains this, right? So you have to have in mind that each row is a list of numbers. Each row is a list of numbers. Now, how do we represent that in Python? In Python, for you to have a matrix, you need to make sure that you have a list inside a list. So first, so matrix, let's say A equals to, you need to first have a list that we have, like a vector first, and inside this vector, then you put the individual rows. Individual rows are supposed to become like a list of numbers, and then another list of numbers. So this one can contain 1, 2, this one contain 3, 4. So there's an outer matrix, an outer bracket, right, that encompasses the row. So a matrix in a list in a list gives you a matrix. A list inside another, a bigger list, give you a matrix. So you have 1, 2, this is row 1, so this is row 1, and this is row 2. So we are going to take our time step by step to actually understand, but you have to know that for you to make a matrix, you need to have a list inside a list, and each list in the list, each list inside each inner list is a row. Each inner list is a row. Each inner list is a row. And while you are creating that, make sure that the number of items in each inner list are the same. So you have 1, 2 here, you have 3, 4, meaning that okay, they have the same number of items in each row. So if we are to add another row, we'll do the same. Let's go to our Python interface. So yeah, so last time we were able to create rows, right? So now let's use another cell. Yeah, creating a list. Let me creating matrix. That's what we are going to do, right? So first we say a list contains what? A matrix. For a matrix to, for us to have a matrix, we need to have a list in a list, right? And each list in the list, each inner list is a row. So I can say row 1, row underscore 1 is equal to so let me have each row. Let me say this one is 1 comma 2, right? So the second row, I'm going to say row 2, row underscore 2 equals to 3 comma 4, right? Let me just create this simple one. Okay, so it means that for us to have a matrix, so the matrix is going to have so let me call it pi list. Pi list equals to, so you have an outer list, right? That will contain row underscore 1 comma row underscore 2. So what we are seeing is that I'm having a list here, right? And that list there will contain row 1 is this one, and row 2 is also going to be this. So actually they are in a list in a list. This is what I'm doing, right? So now we need to actually create the array, right? How do you actually create a vector array? You remember we have to use the NumPy vector, right? np.array. But here, because we are going to create a matrix, so we need to import it. All import should be done at the top, right? From NumPy, let's do import NumPy as np. So now creating the matrix here. So we said matrix equals to np dot array, right? Then we'll put the pi list inside. Now let's run this. It's coming, it's running. Now we have to actually print the matrix, right? I'm not printing the matrix, so let me call the matrix. So you have it like this, right? Or let me just print it. If you don't understand it in this format, let me do print matrix. So yeah, you see that you have 1 2 as the first column, first row, and 3 4 as the second row. It's coming like first row and second row. That's it. This outer bracket are for the list to is the outer list, but the one inside is for each row. This same thing we could directly just go and say matrix list, matrix underscore list is equal to, so we can create a bigger row, right? The outer row first, open it up, right? I open it up so that I can see it very well. I can do this one. The first one is 1 comma 2, then I'm outside is the comma, then I'll go and call the next one, the next row, 3 comma 4. This is another way to directly do it if you know your items. If you are not confused, you can do a row 1 so that you can say, okay, this is my row 1, and then you can clearly also see your row 2. After you see your row 2, then you put them together to create a Python list, a list in a list, embedded list, right? Then you use the array on it. But then if you can, the other way to simply do it, if you know your row and this thing, is just to basically create a matrix list, right? Remember, the matrix list is the Python list itself. Is the Python list itself. But now you need to convert it to actual matrix so that NumPy will be, we can do NumPy operations on them, right? That's why you need to use array to convert it to a format that the NumPy will be able to understand. That should be an actual matrix. So I'll do matrix list here, matrix underscore list. So if I do it, I'll get the same thing. So let me do this one, 3 7 9 4, right? So let me run this. So I have 3 7 9 4. So this is a matrix that is having a 2 by 2 matrix. You can add as many rows that you want, right? So you can have like 7 comma 1. You can add another one. Remember the comma before. Then if you are adding another row, make sure you bring the comma before you move to the next one. What I mean is, if I want to add another row, I'll do comma and then go to the next one and then add it. Do 3 comma 2. Let me run this. You see, if the comma, then it helps. If the comma is not there, there will be an error. Let me run this. There's an error, so we needed to bring this comma here, right? Now everything is set. So remember how to create a matrix. Remember how to really create a matrix from a list. You can either go one by one. So you define all your rows, then you put all your rows in one major list, right? Then you'll be able to print it to have your matrix. Or if you know that you can just create it as just a matrix, then you write them one after the other to create your own matrix. This is how to create a matrix in Python using the Python array. Get the matrix list first and then use the array on the matrix list, and then you have your matrix in a form that NumPy numerical operations using Python can work on it.